Alright guys, go ahead and get started here. I don't expect too many people to show up. This is the first stream, so hopefully you guys can hear me and there's no technical problems. So what we're going to be building out is this endless space shooter, and the goal here is that you have a ship, you can fire bullets, and you've got these meteors that endlessly generate and come down. And of course, you shoot them to score, and if they hit you, then it's game over. It's pretty simple. Nothing fancy about the graphics. They're just kind of standard graphics. What we're going to be learning, though, is one, how to build out an endless runner type game. Now, if you watch the Flappy Bird demo that I did on the YouTube channel, in that demo, we learned how to do object pooling. And so this is kind of the opposite of object pooling. What we're going to do is show you here. We are going to create, all right, now it's not working. Here we go. We're going to just instantiate objects endlessly. That's meteors and the bullets. And we will have a system, and you can see over here, these meteors, they're getting cloned. You can see them coming in and then fading out. So what's happening is we're generating those and then they're getting destroyed. And we have a system set up to do that. So it's kind of the opposite of object pooling. And there's pros and cons of both, but the reason we're doing this is just to show you them, because in game development, there are many, many ways of doing the same thing. And there's really no right or wrong answer. In general, it just depends on what you're doing and what you're trying to achieve. All right. So that's it. So the point of the game, there's no win condition. You just go through and try and get the highest score possible. And we have it set so, oh, now I have a compiler error. All right, that's fine. The challenge of the game is the more meteors that you destroy, the higher your score goes, and the faster the meteors come through. There's not really much more to that. If the meteors get past, there's no damage. There's no punishment for that. They just fly through. So as long as you avoid them, you can go on forever if you like. Okay, so let's go ahead and just exit this. And we'll fire up a new Unity. Now, if you don't have Unity, you can go over to Unity3D.com and download the community version. That's all I have here. It pretty much has everything that you need to build any number of games that you want. The Pro package comes with like a profiler and some other things, but you don't really need those until you're, putting out big games. Okay, so opening Unity, we're going to go over to the New tab. We'll start off by putting in the project name. This is Space Shooter, or maybe we call it Space Blaster. That's better. And then we'll give it a location, Space Blaster, and we'll choose 2D. So this is where you determine the type of game that you're going to build, 3D or 2D, and Unity will set up the environment and the world for you. Create the project. Now my computer is really old, so sometimes these things take a while to get set up. There we go. All right, so this is the first thing you'll see. This is pretty much vanilla Unity. I have not changed any of the settings. This is good enough for me. I'm sure as I move on, I'll rearrange things to better suit my needs. But the first thing you see is services. We're not going to use any of this, but you can just see the types of things you can do. Ads for monetizing your games. You can add in analytics, see how people are using and playing your games. Lots of other things here. We'll just click on Inspector. This is the window we'll be using most often. All right, so we've got our scene view here. And then up here, we've got our game view. So scene view is where you'll do all your work. And the game view is where you'll preview or play the game as if it were the final product. You can change these around if you want. Some people like to put them over here so you can get a preview while you're working in the scene view. I'm not really a fan of that, but you're welcome to do whatever you need. Now these other ones, Asset Store, you can go and purchase pre-made assets in Unity. Some are free, some cost money. We're not going to be doing that in this session. And then the animation and animator, we'll be getting into those in this session. They're not open by default, so you can go up to the window and you can open those in the window menu, animator. And the other one is animation right here. Let's go back to scene mode. Okay, so the first thing we want to do is set up the camera. You just want to change the size. Now, this is, I figured this out through trial and error. We're just building out a desktop game. You can change the target platform. You can go to Android or iOS, PS4, Xbox, whatever. We've just got this set for PC, Mac, Linux standalone. And you can see the other options here. And there's even more as extensions and plugins. For now, PC's good. We're just trying to learn how to build games with Unity, so we'll leave this stuff alone. All right, and then the next thing I want to do is change the background color of the camera to black. So instead of that blue color, now it's black. And the reason we want to do this is because there's a chance that you may see a seam in our scrolling background. And if that happens, when it's blue, it's going to be very noticeable. So change this to black, just makes it a lot better visually in case something like that happens. Okay, so over in the game view, we want to change our aspect to 5:4. And there's other options in here, so 16:9. You can set your own resolutions. I was playing around with building out a Mario game, the original Super Mario Brothers, and I tried out the NES resolution of 256:240. So there's that. 4:3, and lots of other ones. And of course, you can set your own custom aspects to whatever you need. If you're going to be doing Android, let's say, for a mobile device, and you choose Android in your build settings, this will have a list of portrait, landscape resolutions that you can choose from. Okay, so we'll just choose 5:4 right now. And we're going to start off by creating our game manager. So we'll do that by right-clicking, create an empty object, and we get this new object in our hierarchy. And we'll call this Game Manager. Now this is just an empty object. It doesn't do anything. There's nothing in the scene, nothing attached to it. It's just there. And what we're going to do, we're going to attach a script to it. So we'll come here to Add Component. And what we want to do is type in Game Manager. Now this is going to be the name of our script. And what happens when you type in the search box is it will show you a list of available options. So we wanted to add a rigid body 2D or rigid body. Those come up because we started to type in rigid. Now if something doesn't meet the criteria, which is usually what happens when you're typing in names of custom scripts, you will always have the option to create a new script. And that's what we're going to do here. And so we're going to new script, name is Game Manager, and the language is C#. Now there are other options. The other option is JavaScript. I'm not sure why it doesn't show up here. It may have been the options I chose during the install. I'm going to be doing all C# all the time, so we'll choose C# here. Okay, and then we will create that. And you'll see underneath this object, Game Manager, now we have our script, Game Manager, and it's grayed out. That's okay. We're going to double click on this, and it's going to take a while, but it's going to open up Mono Develop. Eventually, here we go. Now, I also have Visual Studio 2012, 2013, 15, and 17 installed. So if you have those installed, you can use those as well if you don't want to use Mono Develop. I thought MonoDevelop might be a little bit faster, less resource intensive than Visual Studio, but it has some downsides to it that I don't really care for. After all, I'm very used to Visual Studio. Let's go up to, let's see, somewhere in here. Preferences and external tools. And then for the external script editor, you can click the drop down. Whatever you have installed will show up here. So as you can see, I've got a bunch of Visual Studios. I should probably get rid of some of those. 2010. All right. MonoDevelop comes with Unity. So by default, if you don't have Visual Studio or you don't want to install Visual Studio, you can just use MonoDevelop, which is pretty nice. During the Unity install, it does give you the option to install Visual Studio 2017 Community. So it takes care of that for you if you still want to use Visual Studio. But for now, we'll use MonoDevelop. All right. And we're going to create this game manager script. And the first thing you'll notice is we created a new script. And we've got our game manager. It's the name of our class. And it's going to inherit from mono behavior. So they're all going to start this way. And they start out with a start function or start method and an update method. So the start method is called once when the object is initialized or started. And then this is the update method. It gets called once every time the update loop or the game loop fires through. So this is where you'll do all your game logic in the update. So for now, we're actually going to set up a few variables. Set up a public static game manager instance, and this is going to be a singleton that we're going to use. Now this is something I'm not going to show you the other way, but we're going to need to access variables or members from our game manager from other classes, and there's methods to go and search and find the game manager and get a reference to it, but I think that's really sloppy. I think the singleton is a much better way to go, so that's what we're going to do here. Okay, we're going to set up the score text. This is the text that you'll see on screen that will show our score. We're going to set up a public game object. And this is for the game over text. This is the text that will show when the player has died. Now the reason we're using a game object here and a text object here, even though they're both going to be text UI elements, is because the game object, we're going to be turning that on and off. And I don't know the exact reason why, but text, for some reason, doesn't like to be turned on and off. So it just makes it easier. It doesn't really impact what you can or can't do with it, other than turning it on and off, of course. Then we're going to set some private variables. This one's going to be score, just an integer. Is game over? Oops. Typing skills are off tonight. And then our meteor speed. So this is the speed that the meteors will be traveling. And this one is public because we're going to be accessing it and changing it from other areas of the game. Okay, so the start method, use this for initialization. We actually don't need this, start at least. What we do need is awake. So awake is called earlier on in the sequence, or earlier on in the life cycle of this object anyways. And we want to do it before start is called. And now we'll set up our singleton. So if instance is not equal to null, then we want to destroy game object. Okay. Otherwise, instance is equal to this. So what we're doing here is we need to set a single copy of our game manager instance, and what will happen, or what could happen, is multiple instances of this game manager could be instantiated. So if that's the case, we don't need two game managers, we only need one. So we have this conditional here. If the instance is not null, means it's already set, then we're going to destroy game object. Now, game object is the reference to the game object in Unity. All right. So otherwise, we set the instance to this. Okay, so down here in the update, okay, so what we're doing here is we're checking to see if the game is over. If the game is over and the player has pressed the jump button, then we're going to use the scene manager and we're going to reload the scene. And so in this case, our scene, we haven't saved it yet, so let's save it. And we'll save it to a new folder called scenes. Don't know if I spelled that right, but whatever. And we'll call it main. So this is our main scene. And you can see that here. So in the scene manager, we're going to load the main scene. So it resets everything and you can start over. So the input get button, we're telling it to get the jump button. And by default in Unity, that is the spacebar button. And we won't get into that in this session, but you can change what the default keys are in Unity for jump. You can also set your own keys or rename them to whatever you want. So if you don't want it to say jump, you could say fire or shoot or whatever. But for now, jump is good enough. Okay. So what this does is if the game is over, the player has died, it's going to show the is game over or the game over text, and it will let the user restart the gameplay by pressing the fire button. Okay. Got a couple more methods here. This one is the add score. We're just going to increase the score, and then we're going to update the text to score and whatever the score is. And also in here, we will change the meteor speed. So meteor speed plus equals score divided by 100. Oops, 100F. And that's because meteor speed is a float. Okay. So far, so good. Now, player has died. And we'll set the game over text, set active, and we'll set it to true so that it'll actually show. And then we'll set game over is equal to true. All right. So that's it for the game manager. And then I see up here, text is red. Now this is the one of the things that I'm used to in Visual Studio that I don't really like in Mono Develop, which may be changeable, but whatever. There's no red squiggly like there is in Visual Studio. So if you're not paying attention, then you may not notice this until you go to build. Let's actually save this and I'll show you. There we go. So you can see anytime you have build errors, you'll see those come up in the console here. And this one, of course, the type or namespace text could not be found. And yes, we are missing a using statement. So let's add that in. Using Unity engine.ui. There we go. Now text isn't red, now it's blue, and we're good to go there. So anytime you save, and make sure that you save, because if you make changes in here and you don't save it, then Unity will not be updated. And these errors will just stay here. Oh, I guess not. So they'll go away. If they don't go away, you can tell it to clear. Good to go. All right, so that was boring. let's actually get down to making a game. And in order to do that, we need to import some sprites. Let's go here into our assets. We'll create a new folder called sprites. And one thing I want to show you here is this is our game manager script. When we added the script to the game manager object, it automatically put it in the root of assets. Now, because we called it game manager, it has a special meaning. So it gets a different icon than the other scripts will. And you'll see what I'm talking about when we add more scripts. But this one has a gear icon. So you know that's a special game manager script. So kind of a nice thing. And of course, you can create a scripts folder if you want. And just add the scripts to that folder. So when you do that, you don't have to go and re-reference the script on the game object. So the script is still there. It still knows about it. It's just a logical organization, not a physical one. All right. So back to sprites. So I've got a folder here with these images, and I just drag them in. Now I took these from just a free sample project. So you can go out and find your own. I will have these available for download after the stream, so check for those. Other than that, they're just pretty basic sprites. This one is the meteor. We've got our bullet. This one is our jet, and you can see the preview down here. This is our airplane or spacecraft, and then our sky background. All right. Just check chat here, no chats. So let's start off with our background. I'm going to drag our sprite in there. Now let's scroll screen view out. And with our background, we want to change our... let's delete this. I'm going to change our pixels per unit. And we'll set that to 50. And yep, we need, hit apply. There we go. Okay, so it's what that means is how many pixels in Unity will equal 1 meter. So Unity is based off meters, so there will be 50 pixels per meter in Unity. All right. Okay, so we have our star background. Now we're going to need to do some sorting. We're going to have our ship and our meteors, and we need to change the order in which they're drawn. So we can do that on the game object. We choose sorting layer, and by default, it's on default. So what we'll do is we'll add some layers here. So we'll add background, foreground, and UI. Now the way this works is the topmost layer will be the one that is drawn first, and the bottommost layer will be drawn last. So anything that is in the UI layer will be on top of everything else because it's drawn last. All right. So now let's change the sorting order to background. Okay, and now we need this to scroll because this is an endless runner. So this is our background. We need it to scroll multiple times. Now to get that effect, we need to duplicate this. So we'll right click, duplicate, and then we just need to make some adjustments here. So we will set the scale. Oops. Let's actually set this, zero this out. We'll set the Y to 20. So as you can see, we've got another copy of our star background up here on the top. And we just want to give this a scale of -1. And what that does is it kind of flips the image. And the reason we do that is so that this image wasn't meant to be repeatable. So by flipping them, it just kind of makes it look a little bit better when it's actually scrolling through. Less noticeable that it's not meant to be tiled or scrolled. So we just flip that over, -1 on the Y. Okay, so now let's add our scrolling background script. So again, add component, type in scrolling background. The only option is new script. create an add. Okay. Oops, and so you can see here. So now the script shows a C# on a piece of paper instead of the gear. So this is what your normal scripts will look like. All right. So for our scrolling background, so public float speed is equal to -2f, and we want -2f because we want it to scroll down. If it were positive, it would scroll up, and we'd essentially be going backwards, so we don't want that. We don't need this start method. So we will use transform that translate, and we're going to give it 0f for the x, speed times time.delta time, and 0f. Okay, so what we're doing is we're telling the game object that we want to translate its position, and we use that using the transform property, and then translate. And this is a vector 3, so it takes in x, y, and z. We don't want it to move on the x or the z, so we just pass in 0f. On the y, we're telling it to scroll speed, so -2f, times the delta time. Now the delta time is the amount of time since the last time this update method was run. All right, so we get the nice smooth scrolling effect there. Okay, so now we need to do some trickery here with our backgrounds. So what happens is we need to check the position of the background, the Y position specifically. If it's less than or equal to -20, which means it's scrolled past its height, then we want to move it back to the top. Don't worry if that doesn't make sense. Let's go add that same script. Come on. Okay. So now when we go to type in scrolling background on our other background game object, now it shows up in the list. We still have an option for new script if we want, but we also see scrolling background. So we can reuse these scripts and apply them to any game object that we want. Okay? So that's good. And that should work. So let's hit play and see what happens. All right, there we go. Now we've got a scrolling background. And there's no seams, so that looks good. Now over here, let's scroll out so you can see what's happening. So you can see we're just moving each of the images down, and then once it gets past a certain point, it relocates it back to the top, and it just does that over and over and over again. All right. So there's that. That is the background. Super easy. All right, so let's do our spaceship now. So we have our sprite. Now if you double click on this, you can see that it's just a PNG image, and it's got 4 different images in here. Now they look the same, but they're not the same. You can tell in this one, the actual jet flames, they are different. And this is going to be our animation. So we need to split these up. So the first thing we'll do, we'll click on spaceship sprite, and we'll change the sprite mode from single to multiple. And the reason we do that is because it's not a single sprite. It's actually a sprite sheet that contains multiple sprites. Okay, hit apply. I always forget to hit apply. So then we hit the sprite editor. So the sprite editor brings up this tool here, and this allows us to split out the sprites. And sometimes This is easy, sometimes it's not so easy. So there's different options. Up here we click on slice, and there's an automatic option. Now this is kind of nice if everything is uniform, but in this case, and you can barely tell, oops, that's not what I wanted. It's all right, we'll revert that. You can see it's created actually for each frame 3 sprites, and we don't want that because they're not individual sprites. So let's revert. In this case, we will do grid by cell size. And the grid is 116 by 140. And I know this because with the sprite sheet came information about the frames, and that's what it said those cells are. So let's slice that. And now let's have a look. Okay. So now we have 4 individual sprites. Okay, now if you don't like that, you can click revert. Or in this case, we want to apply. So after we apply, now we can click the fly out, and we have 4 individual images, sprite images. So that's all there is to splitting out sprites. So let's get this into our game. What we're going to do is take a shortcut. We're going to highlight the 4 frames. We're just going to drag them over to our hierarchy. And it brings up a new animation window, save dialog. Okay, animations, and we'll save this as ship. And the reason it brings up a save animation or create new animation dialog is because you're adding multiple sprites to the hierarchy. So obviously you're going to want to set up an animation. So you could do this manually if you wanted, going into the animation pane and dragging your images into each frame one by one if you wanted. That's also an option. In this case, we didn't need to do that. All right, so as you can see, or not see, our spaceship is invisible, and that's because the sorting layer is by default, or the sorting layer is default, which means it's the furthest back. So we need to change that to foreground. And when you do that, now you can see our spaceship. Problem is the spaceship is upside down. So let's go ahead and we'll set this back. And we'll just flip it around by changing the Y scale to -1. And then we want to move its actual position to -5 on the Y. Scroll this out. Okay. So now we're towards the bottom of the screen. That's where we want our ship to be. So in this particular game, we're only moving on the x-axis, back and forth, left and right. We're not going to go up and down, diagonal, etc. So we just position it where we want on the Y, and it'll be static. Okay. Now we need to add polygon collider, because we need to know when something hits our ship, because that is the death condition. And to do that, we just add in a polygon collider. Now there's different types of colliders. There's a box collider, circle collider, and you can imagine what those look like. We're just using a polygon collider here because it's a fairly simple game, and the ship has kind of a weird shape. So we don't want a meteor to be, over here. If we were using a box collider, let's show you that. Box collider 2D. So it's important you use the 2D options when you're in a 2D mode. So you can see there's a lot of empty space here. So if there was a meteor right here or an enemy and you were just moving out of the way, in real life it would miss, but if we had a box collider, it would hit and the player would die, and that would be annoying. So we don't want this box collider, so we can click on the gear icon, remove component, and it goes away. And we'll re-enable our polygon collider, and that's all we need. Okay, so there are, I don't want to say 2, but there are different options. So right now, because this has a physics engine, if something were to hit the ship, because it's just a regular collider, physics would kick in, it would bounce off or do something odd. We don't want that to happen. We just want to know if something has collided with the ship. And so instead of applying physics, we just want to get a signal that says, hey, something collided. And we do that by turning on isTrigger. And we'll write some code to wire that up in just a second. Okay. All right, so let's set up our ship script. We'll call this ship control. New script, create an add. All right. So the ship control obviously is going to be used to control how our ship moves. So we'll start off by adding some variables. We'll set the player speed. We'll set that to 10F. Set a game object. And this is our bullet prefab. I'll show you guys what prefabs are in a second, but this is essentially the image or object we're going to use as our bullets when we are shooting. And then one more, a float for reload time. And we'll set that to 0.25F, okay? So this is the amount of time in between rounds that we can fire, bullets that we can fire, so the bullet fire delay. We don't want the player to be able to just hold down or spam the fire button and just shoot bullets all over the place. So there's got to be some challenge to it. So we just add a delay in there. Elapsed time, we'll set that to 0, and we're going to use that to keep track of our reload time. So you might be wondering, why did I make this private and make these public? Good question. So on these game object scripts, anything that is public, let me save this, will show up in the inspector for the script. Here we go. So our player speed, our bullet prefab, which we're going to use, we're going to set that later on. And then our reload time. So if we wanted to control these as we're playing and the player speed is too fast or too slow, we can set it to 5 instead of 10. And what that does is it sets it to a value on the instance of the script. So if we actually set 5 there and we come back to our script, it's still 10 here. It doesn't change the value in the script. Okay, so I should put that back to 10. All right. And then, of course, private, those will not show up. So as you saw or didn't see, elapsed time was not something that we could change in the inspector for the script. Okay. We don't need to instantiate anything here, so we'll get rid of start. So in our update, we'll set elapsed time plus equals time.delta time. Now remember, delta time is the amount of time since, or that has passed since this method was last called. Okay, and then we'll set up another float for our movement on the x-axis. And we'll use input.getAxis horizontal. Make sure I spelled that right. Okay, so what we're doing here is we're actually getting the movement on the horizontal axis. Now again, these are preset in Unity, so this could mean for the keyboard, the left and right arrows, the A and the D keys on the keyboard, on a gamepad, the left and right on the D-pad or the joypad, whatever the case is. So whatever they're using, we just want to know what is the horizontal movement left and right. And then we'll times that by player speed, and then time.delta time. Then we're telling the game object we want to move it using the transform property, and we'll use translate. Use our xmove. Should probably name that better, but whatever. So we want to move it along our x-axis. So remember, translate is a vector 3, takes in an x, a y, and a z. So we don't want to move it on the y or the z, so just our x movement. Okay, so we use input.getButtonDown jump. If the player has pressed the jump button or the fire button, and the elapsed time is greater than the reload time. I suppose that could be greater than or equal to. Then we'll set up a new vector 3. This is our spawn position. And what we're doing is we're using the position of the current object, which is our ship or our player. And we're just going to set that spawn position to the same position that our player is in currently. And then what we want to do is plus equals new vector 3, 0 on the x, 1.2 on the y, and 0 on the z. Now, the reason we're doing this is because we want to first position the bullet. We're going to fire a bullet here. We want to position it in the same spot as the ship, but we want to put it slightly in front of the ship. Okay? So that's what we're doing here. We're adding 1.2 on the y-axis. And then we're going to use the instantiate method. Going to give it our bullet prefab because it's expecting a game object. What is it that we want to instantiate? Give it our location, so our spawn position. And then we'll just use this guy here to determine the rotation, and we don't want to change any of that, so we'll use dot identity here. And then we'll set the elapsed time to 0. Okay. Good deal there. Okay. So we got player movement and we have our shooting. So we've got that taken care of. Now we need to know, what do we do when something collides with our ship? And we do that by setting up a void on trigger enter 2D. And it takes in a collider 2D. Okay, so where does this method name come from? These are actually, you can look them up in the documentation, but these are methods that are expected to be there on certain conditions. Convention over configuration, you're not going to set this anywhere. You're not going to attach any events. It's just Unity is expecting this method to exist so that when the collision event happens on the collider, it's going to try and call this. Now, it doesn't have to be here, so we could run the game without this. It just, nothing will happen when the collider is hit. So on trigger enter 2D, and this one takes in a collider 2D called other. You can call this whatever you want. This is the object that has collided with the ship, okay? And what we want to do here is use our game manager instance and just call player died, because that is the condition. When the ship gets hit, player dies. And then we're going to call destroy game object. And the reason we do this is because the players died and the ship will no longer exist. So again, game object, we're destroying game object. Game object is a reference to the instance of the ship. Okay, so this is, we're not using this because this would be an instance of our ship control script. We are trying to destroy the actual ship game object, and this is the built-in reference for that. Okay, so game object will be, if we attach this to the ship, game object will be a reference to our starship. If this were attached to the meteor, then game object would be a reference to that meteor. All right. And we'll save that. And that is our ship control script. So let's test that out. Come on. All right. Okay, click play. Okay, so we're moving along, and there we go. Now we can go back and forth, and let's hit fire. And of course, we have an exception here. We can look in our console. And the problem is we have a null reference exception because we have not set up our bullet prefab yet. So it's trying to instantiate something that doesn't exist. So let's stop this. And let's take care of that.